Hello and welcome to the World Built Environment Forum webinar series. Today our webinar is on generative design, a knowledge-based approach to construction. My name is Anil Sawhney. I work in the Knowledge and Practice Directorate of the RICS, focusing on the construction and infrastructure sector. I'm also a fellow of the RICS. Today we are going to discuss this very important, timely, and I guess a bit challenging topic of artificial intelligence, generative design, generative models in construction specifically. Imagine a chat GPT or a Google Bard or Bing style chatbot interface to construction drawings, our documentation, and perhaps even BIM models. No need to imagine that. In fact, many of these tools are being currently developed. You could possibly today use a bot such as ChatGPT to perhaps count, measure, or search construction elements or objects in perhaps a CAD drawing or a BIM model. You can also take it one step further and use this tool to essentially identify inefficiencies and suggest solutions to avoid waste, perhaps also learn from previous issues, root cause analysis, and make your decision making even better. One step further, you can use this tool to look for other inefficiencies, expand further this use of this technology to develop multiple options for the things that you're doing on your construction projects. So AI can help you generate multiple solution sets that you can look at and also connect these back to multiple performance criteria that you may have set up for your decision making and bring your project teams closer to an optimal solution within that option set. It's all happening now, and we'll be spending the next 1 hour discussing essentially these issues that broadly relate to the topic of artificial intelligence and more specifically to generative algorithms. The technology that drives these possibilities that I've just briefly described is AI, and more specifically what's now called the generative pre-trained transformers or GPTs and large language models. Imagine a fine-tuned LLM for the construction sector. When AI is specifically used to develop design alternatives early in the life of a project, we call this the generative design. And this is with us for several years now. We've been practicing and using that as a sector. However, today what we want to do is take that AI or GPT discussion further downstream to other processes and workflows such as risk management, scheduling, and estimating. Furthermore, when AI is combined with automation and robotics, you could perhaps look at other example applications or use cases, especially things that are generally considered dangerous, difficult, and dirty can all be automated with the help of AI. I guess the applications are endless, but this is where we need to take pause and evaluate the broader implications of this technology. What's happening to the skills and competencies that we need, privacy and security issues. I know there's two ends of the spectrum, doom and gloom with AI, or the other end of the spectrum, how can I use AI to do my job better? What's the future of work going to look like? To cover these topics and discuss, I'm glad we have assembled an excellent set of global experts who are going to help us navigate these topics. So let me now introduce our expert panel. The first panelist is Niknaz Aftahi, who's the CEO and founder of aec+tech. She's a global thought leader. Hi, Niknaz.
Hi, great to be here.
Thank you. Next on our panel is Morgan Hayes, who's the Senior Vice President of Product for Alice Technologies. I had great pleasure of speaking to Morgan a couple of weeks ago. Amazing ideas. Welcome, Morgan.
Thank you so much, Anil. It's a pleasure to be here.
Next on the panel is Patrick Murphy, who's the CEO and founder of Toggle.ai. Patrick is a former congressman from Florida and is part of a very well-known construction company from Florida as well. Hi, Patrick.
Hey, Neil, thanks for having us.
Next on our panel is Pim van Wylick, who's the partner of PLANALOGIC. Pim is well known for some of the excellent globally renowned projects, and he's using generative design on many of his projects. Welcome, Pim.
Good afternoon, Anil, and thank you for having me.
So with that introduction, let me just remind you, we always welcome our audience to participate and interact with us. We today have registrations from over 32 countries. Do please submit your questions to our panel, as it is really helpful to engage in this discussion and bring the conversation to life. If you have any, if you're new to these webinars, you should see that you can submit questions at any time using the question box on your screen. We'll pick up as many as we can and try to weave it in our discussion. So with that, let's quickly jump into our first question. That's also going to provide our panel members a chance to provide their opening statement, weave in their more detailed backgrounds and what they are currently involved in. So the first question to all of you, and we'll begin with Niknaz, is what is generative design and how is it currently being used broadly in the built environment lifecycle?
Sure. So, I'm an architect by background, and my first personal experience with generative design is when I was in school at UC Berkeley back in 2014, almost 10 years ago. And I was working on my thesis, and my thesis was designing this invisible public spaces in Tehran, the control city of Tehran. As you know, many public activities in Iran are forbidden, like, art galleries, singing in public, all that. So I was designing these invisible spaces, and with my AI partner, we developed an algorithm with a scoring system. And the scoring system, our main three parameters were invisibility, escapability, and light. And based on these three parameters and the touch of randomness, the algorithm was giving us the most optimal spaces, in the project. So that it was a very fun experience. It was the first time that I began to realize how, this generative system and AI can help us as architects, not aesthetically, not just, creating beautiful spaces, but also functionally, and, make the process much faster and very smooth. So that was my first experience. And then after graduation, I worked as an architect in the Bay Area, San Francisco, various size firms. I worked on various size projects, but all the firms that I worked for had a pretty traditional workflow. Even though I was the design technology director, I was passionate about new tools, always like introducing new solutions, but we never really had a chance to test the generative model in the practice. And then 2 years ago, when I started aec+tech platform, so aec+tech is a community-based database of the latest and greatest AECO tools and technologies and their applications in the real world. I started to learn about many exciting generative design tools and solutions that are out there and their real world, projects and applications. And later today, I'm happy to share with you some of them. So Morgan.
Thank you, Niknaz. So my name is Morgan Hayes, Senior Vice President at Alice Technologies for Product and Design. And my background is in product management for software companies. I've been doing that for 20 plus years. But just before Alice, I was at Autodesk Construction Solutions, and that was my first real exposure to the construction tech space, and it really opened my eyes to how many exciting possibilities we have in our industry to continue to accelerate and improve the built environment. Here at Alice, where we are building a generative scheduling tool, and generative design is the intellectual forefather of generative scheduling. And what generative scheduling is it's a parametric approach to scheduling. So we'll get into this in a lot more detail later on, but effectively scheduling for large-scale projects has been really a function of that particular project manager or scheduler's prior experience. And what Alice does using artificial intelligence is it really creates a whole new world of opportunities for general contractors, EPCs, owners to manage their risk and go about building in ways that they may never have thought of before. And we've actually successfully applied this generative scheduling tool to hundreds of projects all over the globe. So excited to be here and looking forward to telling you more about how we're using generative scheduling. Patrick.
Thanks, Morgan. Again, Patrick Murphy. I grew up in a family business called Coastal Construction, and we're general contractors in the Southeast United States. So I had a chance to work in all aspects of construction, from being a day laborer to estimating to accounting, all the way through the process. And after college, went to work as a CPA at Deloitte, the accounting company. And then in 2012, was elected to Congress. I was tired of complaining about what was wrong in our country, and ran for Congress, and a great team, and ended up winning in 2012. So I served in Congress from 2012 to 2016. Reason why I mention that is because I spent a lot of time thinking about the future of work on artificial intelligence and the sharing economy from a legislative standpoint, and how that was going to impact all of us, but particularly, future generations. And 2016, or actually 2017 exactly, rejoined the family business. And I'd been gone for 10, 12 years, and was surprised, even though I shouldn't have been, of how little had changed in the construction world. The company had grown and all that, but been very little increase in productivity or workflows along the way. So started looking at our financials and realized that the biggest piece of overhead in our construction company, similar to most construction companies, was the estimating department. So decided that would make sense to use artificial intelligence to automate the most time-consuming piece of that, which is the takeoff process. So instead of our humans now manually clicking and dragging and drawing polygons, measuring spaces and lines and walls in pre-construction, our software called Toggle AI automates that process. So we went to market last year. Originally, we built the company just for our own construction company, but then realized it had applications around the world, so we spun it out. But with generative AI and generative design, I couldn't be more excited about the future for all of us. Really excited about the questions to come here, because this is an exciting time. And I think we're entering a period where true generative AI is going to happen in our lifetime and in the near future, where a lot of the workflows that we're used to are going to be turned on their head. And some of the things that Toggle, our AI company, is getting into, beyond just the generative design, is the predictive component of estimating. So the predictive pricing, not getting into the scheduling so much like Morgan and Alice, but looking more at the predictive change orders based on things that should be known up front. So basically analyzing tens of thousands of buildings that have been built, seeing what went wrong, and then be able to project that forward. Because as we all know, the real problem in construction is every time you build something is as if you've never done it before, right? You're starting from scratch. You don't use the history of all this data and all these jobs and project it forward. And that's going to be the big breakthrough that I'm so excited about. So I will shut up now, excited for the panel, and turn it over to Pim.
Thank you, Patrick. It's Pim from Wylick, partner at PLANALOGIC. I have a background as an architect, over 20 years of experience with generative design. One of my first actual jobs besides studying with generative design was the Olympic Stadium in Beijing. I designed the outside steel structure called the bird's nest, basically. And the interesting thing was that actually became a complete design to complete production part, where we generated, besides all of the options within an earthquake kind of environment, made the complete digital model going into a physical model. It was simple because it was a single material one, only steel. So you can actually tailor make the whole model to be built within steel. Then moved on to start my own company, designed the first 3D concrete printed building in Europe, with a building permit, that was basically the same thing, where you have a sort of an interaction between the structural engineer, us as architects, and the 3D concrete printer to really maximize curvature, make it as safe as possible. And about 5 years ago started PLANALOGIC. The idea behind it is that we're stepping away from the NS1, so every building being a prototype, every building being an individual, project that you look at and like it would be a new thing to start. We're actually looking at it. We generate millions of options for a specific site and actually keep all of the briefs open. So normally generative design actually sets constraints. We do not set them, but we then use data analytics to give you an idea on where sweet spots are. So that becomes a detailed brief for architects, engineers, where we can tell you, if you go left, this and this will happen. If you go straight ahead, that will happen. If you turn right, that and that will happen. Sweet spots are here. Do not go there because you will basically ruin the complete business case, whether it's on regulation, sustainability, affordability, etc. But that gives a good detailed brief where everybody can still use their sort of expertise within those sweet spots, but we warn people from the, let's say, day one, where not to go at it.
Thank you, everyone. But this is like a webinar moderator's dream come true, with such an amazing panel with experience on this topic rather than just a basic knowledge. So really 2 or 3 things that hit me. One was learning from project to project, Patrick, you said, and I've heard this before. We as a sector tend to make the same mistakes on new projects. And I think this technology probably has a very low hanging fruit, can tell us, as Pim just said, hey, if you make this decision, move left, you're going to have this much rework or these many issues, or it could probably impact the sustainability dimension versus the economic dimension of your project outcomes. So this is really exciting stuff. And with your experience, I'm going to jump into our next question and broaden this first question essentially and be more specific and focused to your view of the current and future uses of, broadly, as I think Morgan put it so well, generative design for our sector is the forefather of maybe generative estimating, safety, risk, scheduling, and other aspects as well. So broadly looking at generative design, but also other models and other similar related AI tools, what are the current and future use cases of this technology? So Patrick, I'm going to ask you to get us going with this question, and I'm inviting others to jump in as well.
Great. So maybe I'll just jump on to what you were just saying there and just keep that conversation going. With the lack of data transfer. So I'll use an example that happened to one of our clients recently, where they were building call it a 10-story apartment building, and they were a couple floors up, and the superintendent on the job realized that there were no drains in the showers and the bathtubs. They said, holy cow, what are we going to do? They went and they tell the owner, it's going to be a change order, it's going to cost all this money, and it's going to be a delay, and they've got to go, chip the concrete, on the floors below. They've got to, add in the piping and the mechanical for this new, for the drains and all that. And they go to the owner, and the owner says, well, I'm not paying for that. How did you not know there was a drain in the bathtub and the shower? How could you forget? So the contractor goes to the architect and says, hey, why did you forget this? And the architect goes to the engineer, and everyone's sitting there like this. The owner's mad, it's costing more money, the clock's running, right? And you think about it, how in the world in today's society is this still happening, where you're forgetting drains and bathtubs? And it goes back to, Neil, what you just said, that we're not using the data and the learnings of the history of construction and applying it going forward. So I think very quickly, what you're going to start seeing, we're going to be one of the companies doing it, but I'm sure there will be others, where you have predictive change orders, where even in a conceptual or early set of construction documents, when it's not even done, the contractor and the team will be able to apply, and in this case, look at the current new bathroom and compare it to just say 10,000 previous bathrooms that have been built up to code, recent working bathrooms, And the AI is smart enough without you prompting it to say, hey, buddy, you're missing a drain here, right? And your light switch maybe is too high, and maybe it's not compliant for ADA compliant, for a wheelchair to turn around or whatever. There's going to be different things the AI might note and point out to the construction company, maybe the subcontractors and the team, and say, you need to take this into account early on. As I think we all know, that will dramatically reduce surprise change orders, reduce scheduling delays, and all of the finger pointing that happens on construction sites. And you're not going to solve everything, but if you can reduce the change orders by 50%, that's a huge leap forward. And I think that same thought process you could apply to scheduling, and I'm sure Morgan can talk more about that. You could apply that to safety. You could apply it to warranty issues and better material choices, as Pim just alluded to, because we're learning not from scratch, but from everything that's been done in the past. And I think all of these are steps on the way to getting us to, I don't want to call it the ultimate goal, but at least what I can comprehend is this world of true generative AI, not generative design. We already have that. We're kind of getting past that quickly. But true generative AI, where you put in a few parameters. What's the address of the site? What's the budget? And what style do you want, right? And it will spit out an infinite amount of designs, and not just designs, but construction working drawings, mechanical, electrical, plumbing, structural, the whole enchilada. And then we as humans will be able to start tweaking that. I don't think that's overnight, but I think we're starting to put the pieces in place to get there in the near future.
Excellent. Thank you, Patrick. So I think recently I just put in a prompt on ChatGPT and said, hey, concrete slab on grade, tell me the code from master format and unit class. I guess with about 90% accuracy, it can go search and give you the codes from master format and unit class, and you can sort of connect them together. And that's not even fine-tuned for our sector. Pim, since you've had so much experience working on generative design, before we move forward, I was wondering if you could sort of specifically tell us what gains you were making using generative design on these excellent projects that you just mentioned.
Well, it's they were all kind of in different sectors, but the Olympic Stadium, we basically saved a lot of rework, because at a certain point, by the time you go into, we started out with rhinoceros. Before you even had grasshopper, you didn't even have explicit history, the predecessor to grasshopper. So basically we had static data models, and by the time we had schematic design, we redid the stadium 17 times. Every single time Arab, the structural engineer, said this curvature in the eave zone, if you can actually get the radius to be 7.5 instead of 7 meters, you can save tons of steel. That meant we had to build a new wireframe, build everything all over again. Imagine if you add all of the trusses, etc., to it, that's a nightmare going into design development, etc. So we made a parametric model, CATIA, which is basically used by Airbus for airplanes, etc. Cars, BMW uses it. That was basically to get rework and then to make production easier. For the concrete 3D printed building, that was basically to get the maximum curvature out of the 3D printer, because at a certain point it falls over. Certain point the structural engineer says, well, this is too tricky, I can't, really approve this. So you're looking for the limits, basically, which you normally by hand wouldn't have been able to find. And what we're doing now is actually going into the by actually having millions of options, you have context. You can actually find outliers. You can find where our designs actually going wrong. Where have we made mistakes? As Patrick said, if you have 10,000 of bathrooms and somebody can tell you you're actually missing a drain, it's the same in terms of design for a complete building. All of a sudden you can notice, well, your facade or surface to volume ratio is completely off. You will never ever meet emission levels. You will lose way too much heat. You will spend a lot of money on facade because you have excessive amount of square meters of outside surface, etc. So this is all, it's a really wide range, but I've actually used it from initial point first design up until the end. And I think that's the nicest part about it, that the construction sector is so broad that we can use it in every single aspect.
Excellent. Morgan, I'm sure whenever the word options is uttered, you probably start jumping off of your seat. So anything you want to add to especially this idea of options, optioneering, I guess you guys call it?
Yeah, absolutely, Anil. And I'd love to dovetail on both what Patrick and Pim have been saying, which is that what I'm excited about is that generative scheduling is applicable across the life cycle. Like at Alice, we've had success applying generative scheduling in a bid phase for tunneling projects. We applied it on a detailed engineering phase for a phosphate mine. We've done it in a feed phase for a lithium processing plant. So the possibilities for the application of this technology are really, really exciting. It's not simply at the front end of a project or during execution. I mean, we have evidence that we can apply this tech throughout the life cycle. So it's really exciting. And as far as, like, I really liked what Patrick was saying about learning. We'll talk more about that when I think we get into like some questions later on. But yeah, we totally agree that learning and building on the knowledge of how a GC builds and what's been successful in the past is a key part of the corpus to building like a successful AI-based engine.
Excellent, thank you. So with that, I think I'm going to move to the next question, which probably not one of the best questions to ask, but we do need to level set. And I think I've somehow volunteered Niknaz and Morgan to take a shot at this. We want to talk about foundations for good generative design. You already said past knowledge, past experience, historical data, but just for the sake of everyone being on the same page, what are these things and what are their fundamentals in terms of building one or using one?
Yeah, I can start. Yeah, I'm happy to start. So I think one of the foundations for good generative design is a well-defined design parameters and comprehensive data inputs. You know, most people tend to think of generative design as a magic box, as this black box, you know, where users obtain products by just clicking a button. But in reality, it's really an incredibly manual process. So manual, of course, AI is there to help you, you know, to automate the process, but users really has to define each and every parameter, all the criteria and the algorithm. And then these inputs and parameters have to be defined very well. And they include, like everyone mentioned earlier, you know, site conditions, user requirements, environmental factors, building codes, material properties, you know, all that. So you as a user have to input them right and have to know what you are going after. And then I think another important foundation is establishing the right feedback loop. So having the human judgment piece in the process, assessing the generated options, you know, and refining all these optimized solutions so you have continuous improvement in the process. And the last one I'm thinking of is the collaborative decision making. That is very important too, you know, collaboration between all the stakeholders. That's also important. And then thinking about all these like couple of hundred tools and case studies that we have now on aec+tech, I think having a user-friendly interface, because like in the past, all these technologies were only for, you know, a minority group of like tech experts and, you know, professors and people who have special skills, but now it's changing and these technologies are becoming very user-friendly. So everyone is comfortable using them and incorporate them into their existing workflow. So that's also important. So everyone can really connect with and work with.
Morgan, in your view, what are some of these foundations for a good generative tool?
Sure. It's very similar to Niknaz. There's really two inputs that we think about and one output. the two inputs are your means and methods. Like, how do you build? That includes both the actual like methods by which you accomplish a particular scope, as well as your sequencing approach. So digitizing your means and methods, which like frequently in the case of a lot of the customers that we work with, live in the heads of field leadership, and getting those means and methods and sequencing approaches into a digitized form is critical for many reasons. The second element is constraints, and those constraints can vary by project and many other factors, but getting those constraints modeled in a way that reflects your strategic approach in the market is a second input. The output for that is really getting these elements into a form that's reusable. Ultimately, I'm not sure that there's going to be a one solution in the market. I think there's going to be a bunch of different solutions, and there's going to be a bunch of different solutions for different segments. Togo could be a great example of, you know, an estimation solution, and I don't envision a world in which we lock in GCs, EPCs, owners into one data stack. I really think that if we are focused on having a great interface, like that's and a great tool set, making sure that the data is readily movable and transferable from solution to solution is going to be critical. So 2 inputs, 1 output.
Excellent. Thank you, Niknaz and Morgan. So recently I made the mistake of putting in a LinkedIn post saying essentially rework is the biggest enemy of decarbonization. I stepped out of my house, and for the 6th time I saw the subcontractor come in and demolish the sidewalks, the curbs, because of inspection failed. I mean, a new community where they're going to put in the final touches and leave the community soon, the home builder. But this was the 6th time they came, and I took a photo, and I think was not a wise idea to quickly jump on LinkedIn and say rework is the biggest enemy, and somebody pointed out, no, it's not the biggest enemy, perhaps one of the enemies. So rework, if you can just, we've been admiring rework for 20 years and the waste that it causes. I think if we are able to use this technology to avoid some of that waste, some of that rework, it will be a huge advantage. So my next question, Morgan, to you, and again inviting others to contribute, especially Pim, what are the significant advantages of generative algorithms? And Pim, perhaps you already talked about advantages of generative design. So let's focus broadly on other generative algorithms, if you can get us started. Morgan.
You wanted me to get started? Sorry.
Morgan and then Pim. Sorry for the confusion.
Yeah, no, okay, perfect. Yeah, that's what I thought. Sorry, Morgan.
Sure. Yeah, no problem. You know, I loved this question when we were going through it earlier this week, and it took me a little while to think about like really how I wanted to summarize it, and I settled on 2 things. I fundamentally think that generative scheduling is about 1, risk mitigation. That's a common theme, like Patrick's example of the drains is a great one. We are at the heart like about mitigating risk. How do we avoid forgetting drains in a building when we're several floors up? How do we avoid not getting a particular component for a compressor at a mining facility when we absolutely have to have it? So I think of generative scheduling as a risk mitigation tool. And another great example of like how you mitigate risk would be at the beginning in a bid phase. Hey, you're going to bid based on like this new subway extension based upon the way that you did the last several subway extensions. With AI and generative scheduling, you're no longer constrained by that. You're able to mitigate the risk inherent in your past approaches by exploring other approaches without having to have had direct experience with them. So one, risk mitigation is a major advantage. The second one, and we see this a lot, particularly with our execution-based use cases, is it's about creating a higher quality conversation between the GC or the EPC and the owner. We see a lot of value in, hey, look, I'm not sure that we're on track for this milestone here. And without a generative scheduling tool, that owner is really at a disadvantage in that dialogue. Hey, how do we get this project back on track? By providing, an AI-based tool set, we're really creating the opportunity for a higher quality conversation between owners and their GC EPC partners, because they can explore, hey, look, what if we changed the overtime model for our electrical crews here? Or what if we redid this sequence here? That dialogue is really not feasible at scale for owners today. So we're really excited about those two benefits of generative AI generally. One, risk mitigation, and two, creating a higher quality dialogue between owners and their partners.
Pim, if you can sort of, I know you've already addressed this, but maybe specifically talk about material substitution from a decarbonization. I know you will address that towards the end, again, connecting multiple opportunities of optimizing for various outcomes. What are some of the advantages in the design phase of what you have done?
Well, I think well, I really love it, Morgan, that you're calling risk assessment, because that's a big one from day one. If you already make the wrong assumption on day one, and you're choosing an option which might sound quite good, but even the slightest change will actually push you off your sort of track massively. That's way too big a risk. You want to have multiple options. If you go along, you know there will be outside forces. You do want a bit of margin. But what we see is, trust is one that actually works. If you can show people, the options, and you can actually show them where they're coming from and what the risks involved are, that massively helps. And in terms of materials, the one we see now is, what a big one is synergy. Really, usually generative design is not a, let's say, monofunctional design. You might want to do it, you might want to get the most compact building where you're just looking at, let's say the physical appearance of the building. But then if you can connect all of those metrics like facade, square meters, etc., to a CO2 budget, to a material database, by actually saying, okay, what will be my heat emission or my insulation? If I choose bio-based materials, I will have a lower CO2, but I need a thicker facade package to actually get the same system to work, because I have all of these, the synthetic insulations that actually work really, really well and are thin, but they have a really high CO2 budget that I need for it. But then again, I might have more net floor area, because I have a thinner facade. So all of these trade-offs are now all of a sudden very interesting to see, where what we tend to call the three realities. So let's say, the physical building, that's reality number one, the metrics of it. Then you have the financial reality. So that's, if it's actually affordable, because whatever you make, people need to be able to actually pay a certain rent or pay a certain amount of money for it. And everybody in the system needs to at least, make a small profit to have a healthy company. And the third one being the sustainable reality. That's where, and I mean, all of them, you know, the regulations basically. Do I actually live up to, you know, the regulations? If I want to have a BREEAM, you know, certification lead, a certification, do I actually live up to it? That's the interesting one, because all three of them have forces pulling on them. You know, material shortages drive up prices, so it becomes more expensive. But then again, do I actually substitute a material for something cheaper, but I might not make my CO2 budgets, etc. That's synergy is a massive one to where I mean, it massively helps, you know, the AI part.
Thank you very much. So moving to our next question. I'm going to invite, I guess, Niknaz, if you can help us also talk a little bit about some of the challenge. I'm sorry, I think this was the next question is on challenges of this technology. I'm going to chop this into two separate questions. What I want to do is talk about the challenges of this technology, and Pim, perhaps you can help us with that. And I know, Patrick, you've been now invited to join the President's Committee on these kinds of issues, and you have this broader view of impact on jobs, sort of the negative, maybe press that AI perhaps is receiving. Yesterday, the CEO and founder of OpenAI here in the US went to Congress and discussion about regulation and other issues. So I think what we'll do is start, Pim, with you to what disadvantages do you see of this technology, and then move to Patrick, who can maybe give us a broader view of what's happening in the larger economy.
Well, the disadvantages I see are when it gets to, let's say, black box artificial intelligence, where it's not a rule-based system anymore, but there are softer, let's say, subjective elements in there that where it's almost impossible to measure afterwards what actually happened within that. I mean, the black box. That's something where all of a sudden you have output that no one actually knows how to value anymore. You know, that's what I quite like about artificial intelligence. If it's a rule-based system in a way, you actually have the option to check whatever the outcome was. In some way, as an architect, it takes out rework, it takes out repetitive elements. So all of a sudden you can actually focus on things that you were trained to do, or actually where you're highly skilled to actually do it, instead of doing repetitive elements that might not be, you know, you might not be the best person to actually do it. But in the end, it's getting to the point where let's say the joy in your work might actually be leaving. That's the one where the sort of scary thing, where the sort of unexpected, it's the all of a sudden, if a computer tells you that what you've done is correct or not, that is going to be, as an architect, that hurts. You know, if AI gets so good that all of a sudden you're back in, you know, architecture school, and you have your jury and they go like, I don't like this because of this. It's a completely subjective reasoning, but that would start to hurt, you know, if that's your, and then you can't reason with the AI because it says I'm way smarter than you are. I've actually checked millions of options and I think you're wrong. That's going to be a very difficult part, I think. So.
Very interesting. So Patrick, this just opens up to your discussion on future of work.
Yeah, it's a interesting conversation, right? I don't know if anyone has the answer. I'm certainly in the camp that humans will continue to evolve, and because of this technology, we'll be focused on the higher value tasks instead of doing some of the more remedial, basic, mundane work that consumes a lot of our lives. Checking on various codes, you know, measuring certain spaces. A lot of that can be done by the computer, and allow the humans to remain creative. To Pim's point, where this is really going, I don't know how we get there, but I would just look at a couple stats through the years, and don't quote me exactly in the numbers, but something like 60% of today's jobs didn't exist in the 1940s. Right? You never could have imagined a drone operator or a YouTube influencer or a Uber driver or whatever's next. So humans will continue to evolve. I think the real question is, at what speed and can we keep up? Because the speed of change is happening quicker and quicker, right? Every day, it's so quick. I mean, Moore's law, continues to be true. And if you think back to GPT-3 when it came out, it was just like a few months later as GPT-4, right? And how big of a change that was. What's 5 and 6 going to look like, and how quick are they going to happen? And how quickly can humans adapt to that change? And I think there's a critical role for governments around the world to really think about that and to rethink the education system, to rethink the workforce, so how we are best prepared to handle that speed of change. But again, just looking at the stats, you look at unemployment today, at least in the US, historically low numbers, right? 3.5% or so. You look at poverty around the world, continues to go down around the world. So human productivity does continue to increase with technology, but it's a bumpy ride and it's scary. Oftentimes, not to get too doom and gloom, but tectonic shifts like this, like the Industrial Revolution that I think we are sort of living through right now in a technical revolution, often lead to major world changes and often wars and conflicts and other things because of that shift and that fear of society that they don't know what's coming. And they don't know if their kids and grandkids are going to have as many opportunities as they did because they don't understand it. And I think it's a scary time for society, but I'm generally an optimist, and I think we will pull through with better jobs that humans enjoy doing, where they're adding more productivity to the workforce and to the economy.
Excellent. I was not going to tell anyone, but Patrick, you've now encouraged me to say this. I've just enrolled in a training program on prompt engineering.
Yes,
I was fascinated. Means, wow, how can prompts guide you to get better answers from ChatGPT or any other thing? So the future, perhaps, the new PE may be a prompt engineer as well as our professional engineers. So Niknaz, take us through some of the blockers as you see. Why is it not happening faster? What are some of the blockers to the use of these generative models in our sector?
Sure. Yeah, I think one of the biggest blockers is the lack of awareness and understanding of what generative AI is and what it can do for us as architects and contractors. Like for example, in architecture, parametric design, generative design, are they the same thing? Maybe not. Parametric design usually refers to the style and the form, but generative design is a different story. So I think that is a blocker, and also accessing big data. Generally in our industry, we all know that it's been an issue, open source, big data, sharing data sets. Unlike other industries that most industries have solved that problem, but in our industry, that's still a big issue. And for, all these AI models, you need millions of data, you need big data to, train better models. And also in some regions in the world, big data is something that is not accessible. I recently had a chat with a friend at Ecom Dubai, and he was telling me how they've solved this issue with building their own data sets in-house and then building their own, algorithms and all that. And then it's great they're doing that, but then once companies do that, they are not going to share it with, the world. So accessing big data is another one. Also, the adoption of these solutions. So many of these solutions are not integrating well with other solutions and softwares that companies are using. So AC companies are not going to change their tech stack and workflow overnight. And obviously they're constantly testing, piloting, adopting new technologies, and then for all these like great, exciting generative design tools, it's very important that they make sure their solution integrates well with the current workflow, like with BIM tools, with 3D, CAD, all the 3D modeling software. So integration is also an issue. The fourth one is cost and immediate ROI. Is also a problem. Of course, implementing generative AI technologies requires investment in software, hardware, training, infrastructure, and all that. And then without having a clear understanding and prediction of the ROI, sometimes it's challenging for design and construction companies to invest in these technologies. And the last one that I'd like to mention is the regulatory and legal concern. You know, like with Midjourney, how you are creating all these like great images, but then you have to make sure that, like, one of the things that I realize is that whenever I'm making Midjourney images and renderings, I make sure to give credit to the original, you know, creator and the artist or the designer or architect of the work. So that's also a challenge and concern. Neil, I think you're on mute.
Sorry, do you see the second time on this webinar? So do you see any security or privacy issues also becoming a blocker?
Yeah, of course. Definitely. I think that's also one of the blockers.
Excellent. So let's move on to our next question. And Pim, this perhaps is a very important question personally for me. How can generative models help us design and deliver construction projects and assets that are economically viable as well as socially and environmentally positive for current and future generations? So literally, as you said, just not focus on one dimension. And how do we bring all project team members to this discussion?
Well, I think the interesting thing is that would be the shift away from traditional processes, which are usually waterfall. Let's say the urban planner comes up with an envelope, basically, then the architect starts to build something within that envelope. Then you have a structural engineer coming in, you have the energy consultant coming in, etc. And by the time we have the cost and estimation at the end, it's way too expensive, and we go back. Complete waterfall, architect redesigns, blah blah blah. By that time, usually the urban planning has already been approved by the city, so you can't alter the outside shape anymore. The architect then has a suboptimal envelope and actually continues. I think what AI is allowing us to do is to tie multiple disciplines together, and it doesn't have to be that complicated. It can be, initial kind of setups where you have estimations. Like, I think my budget per square meter for facade should be around that area, because we normally see projects of that. Then you're not even making an estimation on what type of material it could be, but you're just budgeting and seeing what's possible within my kind of budget. But by actually tying multiple disciplines together in one model, you actually get synergy, where all of these millions of options actually show the interaction. So you get a multi-criteria analysis, which is possible. And the nice part about that is that it doesn't have to be one outcome. It can be whatever you actually prefer. If you prefer sidelines more, you will have larger windows. That means it's going to probably be slightly more an expensive facade because you have more glass versus closed kind of area. But that might mean for heating it does something else for your CO2 budget, but that's just your sort of instinct where you go, but I prefer having the views. But the next architect or the other person might actually value something else. So what I find interesting is that it can help us in that way by making sure that you will not have the same outcome every single time, even though you have millions, but it says this one is the best. There is no one best. Since it's the synergetic approach, it's the best overall, maybe based on your criteria. That's where I think actually it can help us design. It's where, let's say, the architect becomes a sort of editor-in-chief. Of a magazine. You actually have a theme number, which can be sustainability for one architect, which can be affordability for the next one, but you filter all of the options coming through and say this one actually fits within the article or let's say the magazine that I want to publish.
Excellent, thank you. So Morgan, maybe just as a follow-up, if possible, I know scheduling, I used to teach scheduling, and scheduling equals time, you can equal resource, maybe cost, but generally don't tell students, at least, and maybe project team members, the broader connectivity. With your tool and with the use of recipes of means and methods, are you able to drive these broader discussions, connecting it to risk, maybe sustainability? What's your view on that?
Yeah, we we believe that fundamentally by exploring the, in many cases, thousands and thousands of viable alternatives, you ultimately create a lot of optionality. You can choose to optimize for time, you could choose to optimize for cost or for your CO2 footprint or for cash outlay. That's what a generative scheduling tool does, is it gives optionality that didn't exist. And that optionality, like it's really interesting. Like we just completed at Alice a process to interview 63 customers and industry experts from all over the world. And what I was struck by was their answers to a question that we had, like how important is reducing duration? And I had a great answer from a super at a GC, and she said, you know, reducing duration is actually not that important to me. I don't want to stress out my crews. What's more important to me is optimizing for milestones. What's more important for me is reducing the risk of meeting these key payment milestones. And so absolutely, generative scheduling, and I think generative AI generally can be a big part of creating more affordable housing, more socially and environmentally constructive practices in our industry, for sure. But yeah, it's definitely not, it's not about optimizing for one variable in our experience.
Excellent. Thank you so much. We're going to jump over to our last question now. And Patrick, if you can help us connect this new generative AI models to our existing design and construction work practices, workflows and tools such as BIM, digital twins, that'll be great. We have about 3 minutes, so I'd like to use this question first, Patrick, if you can answer, as well as provide any closing thoughts, and then I'm going to go over to each of you to maybe very briefly 10-second closing thoughts as well.
Sure. I would just say BIM and digital twins and PDFs and the typical way we do things today will be very different in 10 years when generative AI truly exists and is tangible to all of us. And you know, I'm a little bit hesitant to say that in some ways because coming from the construction background, BIM is utilized in very different ways and often not utilized at all, right? When push comes to shove and the rubber meets the road, it's strong as its weakest link, and we do a lot of, you know, $250, $500 million jobs, and it's not always used that well, and maybe it's only one trade using it. So it's fallen short in many ways, I think, because of some of the complexity. What I think the big difference could be, and I'm hopeful for with generative AI, is that it makes it more intuitive and it makes it more usable, and it puts it at the fingertips of more people. So it's more adoptable really across the board of different education, you know, levels and skill sets for actual, you know, folks in the ground that are doing this construction. So I'm actually hopeful that you're going to see more adoption of tech, even though generative AI is way more complicated, right, on the back end than BIM and other, you know, software. But the user interface will be easier, so I think it's going to be more adaptive. So anyway, I'm again an optimist. I'm hopeful. So this is an exciting panel. Obviously, more to come, and excited for any follow-up here. Thank you.
Thanks, Patrick. Pim, any closing thoughts, and then Morgan, and we'll close with Niknaz.
Yeah, I think generative AI or design will actually get a lot of data, a large data pool that people will start to enhance. So let's say in the initial phase, we will give a rough outline. People will then start to add data to it the way you come. And some people might actually subtract from that and build a BIM model from part of the data for the part that they need. So I see it as this big data pool that people tie into to actually use it for their own little discipline or for the aspect that they actually need it for.
And I'll just add, I think we're at a super exciting time for the implementation of this technology in our space, but it's very, very broad. I think the next step is making specific solutions for specific workflows work really, really well. Because right now it's really, really broad, and if we want to make some real value impact, we got to get a lot more specific about which workflows we really want to impact.
Yeah, and I just want to add that I'm very excited about it, and I'm hoping that it will improve the quality of design. You know, right now in the world, except for just like a few design-oriented architecture firms and you know, a minority group of people who can benefit this beautiful design, the rest are left out. And I'm hopeful that this generative AI can help majority of buildings, you know, benefit beautiful designs and, you know, more options beyond the traditional constraints.
Thank you very much. So with this, I'm going to thank the panel. Thank you, Niknaz. I really appreciate all the help you provided in putting this panel together. Morgan, thank you. We'll continue to work with you as part of our tech partner program. Pim and Patrick, I know you guys are very busy. Thanks for sharing not only your time, but really your expertise on this very interesting and emerging area. So thank you very much to our panel members. Just a reminder to our participants, to our audience, that we'll publish the recording and a written summary of this webinar online. So please do share this with your networks. Please also take a few minutes to let us know your thoughts of today's session by completing an online poll, which will appear on your screens at the end of the webinar. Please also look at some of our interesting events coming up. I'm at the good fortune of moderating the one on 31st May, which talks about giga projects of the Middle East, and another exciting panel that our colleagues have put together, followed by other very interesting events taking place, especially RICS NYU World Built Environment Forum Conference in New York, followed by one in London and Venice, and other interesting topics across the built environment life cycle. So thank you for participating. You can follow us, RICS, as well as World Built Environment Forum on Twitter, Instagram, and LinkedIn, where you can receive information about other events, other publications, and other pieces of information. So until next time, goodbye.
Bye.
Thank you. Bye-bye.
Bye.
Bye, everyone.